So this is just going to be kind of a quick tutorial of what we've been going over this week with our different models for linear and exponential and quadratic regression. So the first thing that we want to do when we approach these kind of problems is go to Desmos, and we're going to make a table for all of our values. So for this, I'm going to just make a random table with x and y values. So I've got 2, 4, 7, 13, 16, and 20, and we'll do one more at 25. But if this were the actual problem, you would obviously put in your x values and your specific y values. So then I'm going to put in 10, 12, 17, 20, 16, 10, and 5. And as you can see over here, it kind of plots the data. So already I can kind of guess, oh, this goes up and then it goes back down. So it's probably going to be quadratic. But I'm going to check all three of my models just to make sure. So the first thing I'll check is linear. So the way we write the linear one is we do y sub 1. And then we do that like the similarity sign, the squiggle. And then we go m x1, and remember it's x sub 1, it's not x1 like x and 1 next to each other, it's x with a 1 below it, and then plus b. So we're putting in just like kind of a y equals mx plus b, except it's not equals. We use this squiggly sign instead to let Desmos know that we want the best approximation for the data. Okay, and so as we can see, this line does not really fit the data super well. And if we look at our correlation coefficient, it's kind of low. We want it to be near -1 or +1. We don't want it to be so close to 0 like this. But anyway, that's what the line of best fit would be for this data. So I'm going to go check exponential next, see if that's any better. So I'm going to go y sub 1. And then this time I'm going to go a times b to the x sub 1 power. Okay, so there's the green one is the best exponential for this data. And it's not great. It's even worse than the line with our correlation coefficient. It does not correlate very well with this data. So there's a good chance that exponential is not what's going to be the best fit for this data either. But we need to check. Okay, so the last thing we're going to check is quadratic. Hopefully that will be better than these. So we have y1. And then this time we're doing a x1 squared plus b x1 plus c. And from here it gives me a much better correlation coefficient. You can see how this orange parabola goes a lot better with our data here. And this is a lot closer to 1 than those other two. So this is the best fit for this data. So I'm going to use the A, B, and C values it recommends, and I'm going to put in y equals negative 0.0827831 x squared plus 1.95933x plus 6.46941. And that would be my equation of my best fit parabola for this. And then if I want to see if x is a certain value, what y is going to end up being, actually I'm going to replace this with f of x instead of y. Because then what I can do, if I want to know what happens when x is 25, or we already have 25, I think, in our data set. Yeah. So if I want to know what happens when x is 30 instead, I could type in f of 30. And Desmos will tell me that y is negative 9.25 when I've got f of 30 here. So that's a nice tool that we can use so that we don't have to type all of this into our calculator once we find our line or our exponential or our quadratic of best fit. All right, hopefully that helps you with the homework. Make sure you read all the instructions carefully and have a great 5-day weekend. See you guys later.